Awesome. Yeah, so the goal of my talk today is I want to go over a couple of different design patterns in JavaScript, and two of them in particular. First one is going to be the module pattern, and the second one is going to be the revealing module pattern. And the goal with this particular study group series is to give you guys a good idea of different design patterns in JavaScript, and then from there you can apply these concepts to the various apps that you're going to be building in JavaScript down the line. And the goal is that the first iteration of these talks is going to be a little more contrived examples. And then as we progress, when I do part 2 of this particular series, then I'm going to go over real world examples. So the examples I'm going to show you today, again, are going to be a little simplistic and contrived. And then from there, we're going to build upon these particular concepts. So again, if you're watching this as a video, then I'm going to be namespacing them part 1, module pattern and revealing module pattern part 1, and then down the line I'm going to have a part 2, just so you guys can get a good idea of how that works. So let's go over what modules are. Modules are an important piece of any application architecture, and they help keep your code separated and organized. And there are a number of ways and a number of options of implementing modules. And for this talk, we're just going to be covering 2 of those today. Again, like I said, first one is the module pattern, second one is the revealing module pattern. So before we dive into the module pattern, we need to be reminded of object literals. So does anyone know how to create an object literal? Luke can't talk because that'd be cheating. Leonard Tripp. You can post it in the chat. There we go. So object.new, that's a way to instantiate the constructor function for object. To create an object literal, we just need the opening and closing curly braces. So you won't be able to do an unnamed because that's going to be considered a block. So that is how we would create an object literal. So let's say I have this object literal and I have a couple of different properties. Let's call it key 1 that has a value of hello. And we have key 2 that's a function. And I'm not going to be using arrow functions or lambdas or ES6 lambdas. We're just going to stick with ES5 for now. And this particular function is just going to log, this is a method named key 2. So this right here is our object literal. We can add additional properties and methods using dot notation if we wanted to. So object.key3 is equal to goodbye. We've got that. That looks good. So then again, that's an object literal. So let's take a look at a more expanded example of what an object literal looks like. So let's say I have this object called myModule, and let's say I had a property of prop1 that's equal to some value. And I'm just purposely adding this additional white space for readability. Technically, you can have them all be one line after the other. Second property is going to be called config, and that's equal to an object. Let's say we have use caching is equal to true, language is equal to en. Say we have another function or method called say hello. Started to do concise properties, but let's not go there yet. Console.log, hello there. And then let's say we want another property called report config. That's equal to a function. Console.log, caching is and use template strings, this.config.use caching. And what that's going to do, we're going to use a ternary operator to determine if we're using caching or not. And it's either going to display enabled or disabled, depending on what this variable returns, true or false.
Don't you need to put the ternary operator inside of the curly braces?
You know what? I did. There we go. Good catch, Luke. Cool. Awesome. Cool. And let's say I had another method called update config, and that's equal to a function where we take in a new config, and then we can just set this.config is equal to the new config that gets passed in. Awesome. We've got this module here, and if we were to reference that module and call the report config method, we can see caching is enabled. Again, we're referencing the module, and then we're using dot notation to grab this method of report config, and then we're invoking that method by adding the opening and closing parens there. And then what we can do then after that is we can reference the module again. If we want to change the config, we can call the update config method. And then if we take a look at that update config method, what we want is to pass in a new object. So we take a look at how the config looks like, it's just an object. So we want to pass in a new object where we can update the value of use caching. It's now going to be equal to false. And now the language is going to be FR. We're French now. And then if we wanted to check config again, we can see here, now we see caching is disabled when we call that report config a second time. So this is, again, just an object literal. But again, I wanted to go over what an object literal looked like before I dove in to the module pattern. So any questions before I go into the actual module pattern? I'll wait a couple minutes on the chat. You want to unmute yourself? Cool. So the way the module pattern works is it uses object literals just like the ones we defined here, but as the return value of that particular function. So the way it works is we're using both public and private methods and variables inside a single object so we can shield parts of it from the global scope. And I'll show you an example of that shortly. And what this does, it prevents naming collisions for functions that you have in other scripts of your application. So it's a way to encapsulate privacy, a way to encapsulate state, and organize your state. And primary function of that is we want to use closures. So with this pattern, only a public API is returned to be used and consumed, keeping everything else within the closure private. So let's take a look at an example of one. So let's say I had a var test module, and we'll set that equal to an iffy. We'll invoke that. So then here, let's say we have a counter that's equal to 0. So this var counter is only going to be scoped to this iffy. And let's name this iffy. I'll just, so we don't have an anonymous function there. So what we're going to do inside this iffy, we're going to return an object. So that's the main point of the module pattern is we're going to return this giant object. And it's going to have a number of different properties with values. First property we're going to declare is increment counter. Can anyone guess what we're doing with this particular property? We're going to return counter incremented by 1. Let's say we also wanted a property called reset counter. So we're going to log counter, counter value prior to reset. We're going to log what the value of the counter is, and then we're going to set it to 0. So that's what reset counter is going to do. And then let's say we have another one called get count. That's going to be equal to a function return counter. Awesome. So again, we have this immediately invoked function expression that returns this big object. So then this variable of test module is going to be equal to this returned object. So now down here, we can start to use those different methods. So how would you think, or how would I implement this increment counter method right here on line 21? Whoops. Did I see my screen?
You have to pass a new counter as an argument.
Oh, hey, Len, can you say that again?
You have to pass in a counter as an argument.
So walk me through what you're thinking.
Well, so far the counter is set to 0. I'm not seeing anywhere where it actually increases to 1 or 2 or 3. Because when you say return counter plus plus, all that's doing is just adding 0, 0, right?
Right. So this is where, again, you know, the way the module pattern works is this counter, we can't access it outside of the scope of this particular function. So the way that we would need to utilize and manipulate this particular counter is to use these particular methods, because these particular methods still have access to the scope of this function. So to increment the counter, I would need to reference the module, because again, what is this module equal to? This giant object right here. Now I have access to this increment counter method. So I would do dot increment counter. And then if we were to console log that, whoops, hang on. Let's call increment counter, and then let's call test module dot get count and log back to the console. There we go. So it was returning the counter before it was being incremented. So I guess technically I could have just done counter plus equals 1. But either way works. But yeah, so we need to access, the only way we can either manipulate or access this counter is by utilizing these particular methods that we return from this function. So again, that's a way we encapsulate this particular variable and not make it known, because then we can't do counter. We're going to get an error. Test module.counter is not a function, because we can't access this particular counter. We can only call these particular methods. Does that make sense?
Hey, Sinab, I have a question.
Yeah.
How is this different from function constructors?
But from function constructors?
Yeah.
What we're doing, we're not creating, and I think one thing that could be differentiating is with function constructors, what you're doing is you're creating a brand new object. You know, and I don't know, Luke, what would your opinion be on that?
I really wasn't listening to it. Was there a difference between doing this or constructor functions?
Yeah.
So the difference between this and constructor functions is constructor functions between this is constructor functions require a new instance to be made, which also allow prototype functions to be called upon them, which is almost an inheritance type of function. And inheritances in JavaScript don't work the way they do in other classes. So you actually build this prototype chain that goes from one link to another link to another link, which actually kind of varies and slows the process down as far as trying to find functions. Whereas this is a factory design pattern that he's showing you right here. It's an immediately invoked factory function. And what that means is you control what's returned with private methods, so that these methods can only be accessed within a variable that's scoped to a function, which in this case, increment counter, reset counter, and get count are in fact private functions that live within inside of a test module, which means they can't be accessed outside of it unless you call the namespacing of the test module, similar to basically class methods in Ruby is what you're doing when you use a factory type function. Whereas a constructor function would be doing everything as like instance methods in Ruby. Class methods in Ruby are much faster than instance methods. Same with JavaScript. You're having a lighter load. You're not requiring it to try to link through all the different prototypes that exist. It's also cleaner code, to be honest. Like here, he's describing the functions inside of the return statement. Most people would probably, if they actually made this more than 2 or 3 functions, would actually do a return object at the top, and they can just call increment counter, reset counter, and get count without even the colons or the function naming, and go down below and actually call those functions down below. So you have at the top of your code, you'd have a return object that you could put 30 different functions in that are named there. So when you found this factory function, you can be like, okay, I know there's an increment counter, there's a reset counter, there's a get count, there's these different methods that I can call. And you can look through the names and be like, okay, if this is easy to use, or if this sounds like what I'm going to use, then you go down the documentation of the function that's there, and you can find out what that specific function does. If you're used to Angular, this would be exactly what a factory is. Versus like a service. A service would be a constructor function. And in Angular, a factory would be actually a factory pattern design. Yeah, it's kind of one of those things where like if you don't have to make an instance of something in JavaScript, you're going to have less bugs, you're going to have faster performance, and honestly, I think it's cleaner code.
Right. And the thing with constructor functions, you know, you newify those, so then those are kind of like singletons. So, and with trip, your question, immediately invoked. Yes. So what we mean by immediately invoked function expression, that's a function expression that gets executed at runtime. So, you think about JavaScript, there's really not a compile time and a runtime, but there's a split second where the code is being compiled before it's run. With an immediately invoked function expression, this isn't being evaluated until the code is actually run. If we had a function right here, this function will get compiled prior to the code being run. But with an IIFE, with an immediately invoked function expression, this gets run as the code is being evaluated. So it's a good way to, again, encapsulate your code and not pollute the global namespace. So that's what we mean by immediately invoked function expression. All right. It could technically make your program run faster, especially if you had, hundreds upon hundreds of IIFEs. Yeah, good question. Because then this isn't getting compiled prior to the code being run. it's waiting until the code is run, then it's evaluating the code. So cool.
So, sorry, I have one more question.
Yeah.
When would you use a constructor function over a module then, since a module is more efficient?
Yeah, let's say that you needed to create multiple instances of a particular thing. So let's say that you had a function person. So there's a constructor function that takes in attributes, name, age, city, something like that. Then you'd have something like this.name equals name. And then you'd have this.age equals age. This.city equals city. And then down here, you do var and create a variable equals new person. And so we're creating this new person, and we're going to pass in that. We're going to pass in that. We're going to pass in that. And then if I wanted to create a second person,
it seems very similar to the Ruby like initialize.
Very similar to that. Yeah. Yep. And then he's cool. And then what we can do now is if we were to log comment out the rest of this code here. Cool. So we have two single objects of type person with their respective values. You know, with the thing with the module is if you don't need to create multiple instances of this test module. You just need one instance, and then you have all the respective methods. Now you can create methods on a person as well. This.sayHello equals function console.log hello, and then you would use the person cernan.sayHello. And then what we can do inside the function is reference that person's properties. So hello, my name is, and then use template strings, this dot name. Because the this keyword references the caller of that object. So because this object Cernan is calling say hello, the this reference is to Cernan, whose name is Cernan, that we passed in here and we set here.
For all intents and purposes, can you just say this is pretty much like self in Ruby?
Yes. Yeah. Very good comparison. Not exactly the same comparison, but very, very close. And then if we think about prototype, yep, go ahead.
I don't know if it's a mistake to like just see everything I see in JavaScript and see how it relates, and like in my mind compare it to Ruby, because it's like there's always not going to be a correlation.
Right, but it's a good analogy. It's a very good analogy, just as a way to compare the two and understand how these methods work. You know, but then we think about person the prototype chain because. And again, we're talking about, you know, don't mean to digress away from the module pattern and go into, you know, this object-oriented discussion here. But, you know, we talk about the prototype chain because every time I create a new person, that new person has their own method called say hello. Well, say hello is going to be doing the same thing for every new person created. So there's no need to allocate space for this say hello function for every new person that gets created. So what we can do is define a function on the person prototype, because every object has a prototype property, and on that prototype property, we can define a method called say hello is equal to this function here.
Hey, Shannon, sorry to interrupt, but
Yeah.
doesn't E6 have a class alternative to the prototype? So it kind of functions like a module.
Yeah, it's class, person, and then you have the constructor.
Right?
And this is just sugar. This is essentially doing what we're doing here, as syntactic sugar. That's all the class, the ES6 class does. But it's very similar. Yeah.
But that can that function like the module? Or no?
No, because this is very similar to the constructor functions. So I would compare this to this rather than this to the module. Yeah. Good question. So yeah, and then prototype. So now any person can still call, say hello, and it will all still work. Because it's going to look the certain object is of type person. It's going to look and see, do I have a method called say hello? No, I don't. Let me look up to the prototype. And then even on the prototype, we can also define properties as well. Person.prototype dot species equals human. So then I can do learn dot species and log back to the console. Cool. All right. So sorry about that, guys. But yeah, great questions on the difference between modules and constructor functions. So yeah, back to the module. So yeah, again, revealing module, or the module pattern is returning a huge object with all the different methods that you want. And these methods have access to the private scope of this function. So while you can't access those variables outright, you can utilize these methods to access those variables outright. But what's one problem with that is, let's say you wanted to, hang on, let's say we had a function that's private. And you wanted to make it public. Then you'd have to go through the whole rigmarole of declaring a new property. I'm still going to call it private function. And do that. So you'd have to take all the functionality on the private side and then convert it into a property in the return object and then put all the code in there. But that can be cumbersome, because let's say you wanted to do that for 10 different methods. Well, that's why somebody created the revealing module pattern. And the way the revealing module pattern works, let's create a new one. Var revealing module is equal. With a revealing module pattern, you declare all methods and all properties as private. So let me show you an example of one. So it's got a private variable. We're calling it a public variable, but it's still inside the private scope. I'm going to declare a function. public function. And then another function called call private function that simply calls the private function. Cool. So all these variables, these properties, these functions, they're all private inside the scope of this iffy. And again, I'm going to call it iffy. And what we want to do, we want this iffy to return an object where the keys are whatever we want to call it for the public API, and the values is the actual methods we want to expose to the public API. So then what this iffy is going to return is just this object here where we declare the keys and the values. So now down here, I'd reference revealing module, because that's the module that we're saving this return value into. And then just call pub func. And let's log that to the console. And we get an error. And why do we get an error? Oh, I did not immediately invoke the function. There we go. There we go. So we're calling pub func, which is the key value, but it's set equal to public function, which is up here. So now we see this is my public function. So that's the way the revealing module pattern works, is everything is private, and then we only return methods and properties that we want to be public in this object here. So now let's say this is a private function here, or this private function, if we wanted to actually make it callable and make it public, then what we can do is call priv and set it equal to priv function. So now this is going to immediately call private function instead of doing the roundabout way of calling this method. So then we would call priv. This is my private function. So again, the main difference between the module pattern and the revealing module pattern is the module pattern just returns one giant object with the methods inside that object, whereas the revealing module pattern declares everything private and only returns what they want the user of the program or the program to have access to. So those are the main differences. Any questions? Chat. Double check here. Cool. Awesome. Cool. So, I mean, that's essentially it. Again, the goal of this lecture series is to first show you simple examples, contrived examples, and then we're going to expand that in the next iteration and go over real-world examples. Just wanted to get your guys' feet wet for you know, how they initially work, and then we're going to expand upon this. And again, like Luke said, a lot of what you do here is very similar to what you do in Angular in terms of factories. So
I have a question, sir. Now.
yeah.
I notice the name of the function is revealing module. So usually you would call, I guess, revealing module and then the open brackets, but it's IIFE. so you don't need to do that. However, IIFE is also the name of the function. So how is revealing module? How do you know revealing module? You should call revealing module instead of IIEF dot call priv.
Oh, right here.
Yeah.
Yeah, and the only reason I put that here is because I try not to have anonymous functions, because this could be an anonymous function and not have a name.
Yeah.
But let's say that you wanted to recursively call this inner function for whatever reason. Then you would want to name it, because if you wanted to recursively call it in here, then you can just call IIFE. Yeah. So it's a way to recursively call this enclosing function that's part of this immediately invoked function expression. But normally, technically, you can just do that and not have a name for it.
Isn't that the right way, or is it not?
I mean, I think if you ask 100 people, you'll get 50-50 response. I try not to ever have anonymous functions. I try to always name my functions.
And why? Is it because, like you said, it does. You can recall it again?
Yeah, if you wanted to self-reference that same function again inside the function, there's no way to do it if it were anonymous. And also, let's say there was an error inside this function. In your stack trace, you would see that the error is occurring in function IIFE. Whereas if all your functions were anonymous and you had an error, then it's going to reference an anonymous function. You're going to be like, okay, which anonymous function is it?
Yeah, you say it's better for troubleshooting.
Exactly.
Yeah. Okay. Yeah. Thank you.
For anonymous functions. No, so that's an arrow function, Ryan. Yeah, so technically we could have made this an arrow function. I didn't want to go down that particular rabbit hole because ES6 arrow functions allow you to shorthand the function. So an arrow function is an opening and closing parens, a fat arrow, and then the curly braces. So that's the way an arrow function. So all these could essentially be arrow functions. So var private function equals the arrow function, but yeah, I wanted to avoid the arrow functions just because I didn't want to confuse anybody. Yeah, so arrow functions, so this is a standard function, standard anonymous function, whereas the opening and closing is what's called an ES6 arrow function. So arrow functions eliminate the use of the function keyword and have an opening and closing parens with the fat arrow equals in the right caret.
And it's basically the same thing?
Basically the same thing, yeah.
Gotcha. Okay, that's what I thought.
Yeah. I'm not sure. I think Trip was in my last talk, but let me point you guys to, I'm going to post it on the doc as well, but so these are my ES6 study group series. I went over arrow functions and let/const. I went over REST operator and default values, and I went over ES6 destructuring. An hour ago, I went over iterators, symbols, and generators, recorded that, so I'm going to post it to here as well as put all these on the lecture doc. But yeah, if you have time, go back and watch these. Very useful in terms of leveling up with ES6 knowledge. Cool. All right, guys. Any other questions before I let you go? Cool. All right, well, ping me on Slack. If you have any questions, send me an email. Happy to help. And I will continue this. Oh, question here. ES7, that's a good question. I am not sure. Technically, it should have already been released, but a good site to follow is, pull it up here. I don't know why it's not pulling up. I would just Google TC39. They're the group that gets together and discuss the state of JavaScript. Somebody put it on chat. Cool. There we go. I would just reference that link. You can even just Google, but right now I don't believe there is a hard and fast date. So cool. All right, guys. Well, have a great rest of the night, and I will see you all next week. Take care.